Welcome back. The scatter plot pointed a finger at roll age. Today we learn the machinery that turns pointing into proof, hypothesis testing. This is the topic students fear most and exams test hardest, so we'll build it from one honest courtroom metaphor, define the p-value without hand-waving, and run a real test in the LeanProjax platform. By the end, alpha, beta, and p will be 3 tools, not 3 mysteries. Let's put the data on trial. Every hypothesis test is a courtroom. The null hypothesis, H0, is the defendant. Nothing changed, no difference, no effect. It's presumed innocent. The alternative, HA, is the prosecution's claim, something is different. Your data is the evidence, and the verdict rule is strict. You never prove the null true. You either reject it because the evidence is overwhelming, or fail to reject because the evidence is thin. Not guilty is not the same as innocent. That sentence alone answers exam questions. The p-value, without fog. If the null were true, the p-value is the probability of seeing evidence this extreme, or more, purely by chance. Small p means your data would be a freak accident under nothing changed. Alpha is the line you draw before looking, usually 5%, the risk of convicting an innocent null you're willing to accept. Decision rule, mechanical, p below alpha. Reject the null, p above, fail to reject. What p is not? It is not the probability the null is true, and it does not measure how big or important the effect is. 2 ways to be wrong, and the exam loves both. Type 1, alpha, a false alarm. You convicted an innocent null, declared an effect that isn't there. Type 2, beta, a miss. The effect was real and your test slept through it. They trade off, demand stricter evidence and false alarms drop, but misses rise. Power, 1 minus beta, is your detector's sensitivity, and the honest way to raise it is a bigger sample. Memory hook, alpha, false alarm, beta, blind. Let's put roll age on trial. I'll use the LeanProjax platform. A 2-sample t-test. Jams in the first 6 hours of a roll versus jams after 6 hours. The null says the roll's age makes no difference. I paste both samples, and the tool runs the test. Read the verdict like a belt. The p-value lands far below our alpha of 5%, so we reject the null. Fresh rolls and old rolls do not jam alike. Age has a real effect. Same evidence the scatter suggested, now with the verdict stamped. Exam drill. 2 questions. Question 1. Your test returns p equals 0.03 with alpha at 5%. State the decision. And what a type 1 error would mean here. Pause here if you need a moment. Reject the null. And a type 1 error means the difference you declared is actually a fluke, a false alarm you accepted with 5% risk. Question 2. P comes back at 0.22. Does that prove the null is true? Take a few seconds. No, you fail to reject. Absence of evidence isn't evidence of absence. Maybe the effect is small or your sample too weak. That's beta territory. The machinery of proof is yours. Null, alternative, alpha before, p after, verdict by rule. Next lesson we put it to work 3 ways. The 1 sample, 2 sample, and paired t-tests, each with a worked example. The workhorse tests arrive. Subscribe and I'll see you there.